Good morning, or good afternoon, or good evening, depending where you're connecting in from today. Thank you for taking time out of your day to come listen to us provide you with another advanced user training on Storyboard. Of course, today's topic is on dynamic memory usage within Storyboard, and more importantly, within the GUI development process. Before we get started, I just want to let you know that today's session, of course, will be recorded. So if you need to drop off at any point in time, or maybe perhaps you have a colleague that wasn't able to join, or maybe you think that would benefit from this presentation, they can always register for it after the fact and get access to it on demand. Of course, we will be providing with live Q&A at the end of the session. So at any point in time, if you have a question about the topic that's being discussed, feel free to input it into the chat section, which you'll find on your screen. I believe it's in the lower left-hand side. And we'll address your questions at the end. Of course, if you haven't yet, please follow us on social media, whether it's Twitter or Facebook, or maybe LinkedIn. And if you ever want to kind of, put something out there, as long as you either put a hashtag of Crank software or Crank storyboard, or even, put something out there about Crank, about using the hashtag of GUI development, we'll follow it, and we would love it. All right, so let's jump into today's session. So we're lucky enough to have with us the lead architect for Storyboard today, Rodney Dodo. He is going to be our main presenter, and we'll be kind of diving into today's topic. And of course, that topic again is dynamic memory usage in GUI development. And so we're going to start things off with a little bit of an introduction into Storyboard. I know many of us might on this session may be familiar with what Storyboard is, but just in case someone is new to Crank software and new to Storyboard, just kind of give you a high-level overview, and then we'll jump right into an introduction into what dynamic memory is, discuss what the key elements are that consume dynamic memory within an application, and of course, what are the best methods to try to reduce this within GUI development. And then Rodney will touch upon some other key elements to consider that may not be as drastic as the other ones he'll talk about, but it's just something to be aware of when building your UI. And then last but not least, we'll jump into the Q&A section. So let's kind of jump into it and give you that kind of overview as to what Storyboard is all about. So really when it comes down to it, what makes Storyboard different is that it provides a foundation for streamlined UI development for embedded products that meets both the UI developers' needs as well as designer needs, and of course the business goals. And what really makes it different is we have a model view approach that really decouples the front-end UI from the back-end logic, but then connects the two with a well-defined data model or events API to allow the magic to happen. So, but what happens is that this clean separation between the front end and back end really allows for UI development to occur early, and for iterations in design to be easily introduced. And then when it comes down to it, deploying on the hardware becomes the final stage. And if changes in hardware occur, it doesn't really derail the entire project, because that front-end UI can really easily be deployed on any type of hardware platform that we support, because we have runtime engines that are really kind of optimized for the different hardwares that we support that really can be put onto it. The other thing that you know is that Storyboard is really not a code generation framework. And what that means is that it's not reliant on hardware or coding to begin in order for UI design workflow to begin. And that, when changes occur, all those changes in coding need to be torn down and built up. It also really kind of removes the barrier of having to have a large team of coding experts on staff in order to build the UI for the embedded project. Also, it has a variety of unique features built into it, such as our graphical compare and merge tool, which really allows the project team to remain in control of the different UI refinements that are introduced into the whole development process. Because as we know, when it comes to building a UI, it's not a matter of if changes are going to occur, it's a matter of when. Because especially when you're testing it and prototyping it, or maybe taking it to your executive team, or even having it field tested with maybe some group of potential users, that everybody has opinions, and we know that things are going to change. And so having a tool at your disposal that really makes it easier for those changes to occur is beneficial. Now, not only is Crank Software a software company creating Storyboard, but we're also a services company. So if I need to have a prototype developed fast for a proof of concept with key stakeholders, or maybe you have an idea but not the time or in-house resources to produce it, or maybe even your company is looking for ways to optimize the performance of your GUI application, no matter what you're trying to create, we have a team of in-house designers and developers that are really here to make your embedded project easier. So, we can help you from anywhere from start to finish, from planning, implementation, to the maintenance of the GUI, or placing it through rigorous testing to uncover any issues that could impact the performance of your product. So feel free that if at any point in time resources are limited, or you really want to take it to the next level but you don't know how, reach out to Crank and our team of professional services to really find out how we can help you. Last but not least, I just want to kind of point out that, again, if you're relatively new to Crank, we have a help center section from our website that has a wealth of additional resources, from getting started videos on the key aspects of Storyboard, as well as a variety of knowledge-based articles, as well as community support. That's all there to really help you out in making the development of your UI application a whole lot easier. So if you haven't been there and checked it out lately, by all means, check it out. And if there's something that you're looking for and maybe you don't see, feel free to reach out to us and put in a request for. Maybe it's a particular article on one particular aspect of the tool that you couldn't find your answers on, and we'll do our best to get that up there in a timely manner. With that being said, I'm going to pass things over to Rodney, who is going to talk about dynamic memory usage in Storyboard UI development. So I'm just going to pass over the controls to Rodney, and he can take it away from here.
All right. Thanks, everybody, for joining. I'm hoping you can see my screen at this point. Scott, we good?
We are good.
Awesome. Okay, so I'm just going to continue on with the presentation about the consumption of dynamic memory within our product, mainly the Storyboard engine, as that is the runtime component, and that is where dynamic memory makes is where it's has the most impact. So I'm going to start off with just kind of explaining a little bit what dynamic memory is. Then I'll highlight within our offering what the highest users of dynamic memory are. And then, as Scott was saying, at the end, I'll also highlight a couple other areas. They're not as drastic, but it's still nice to be aware of where the engine could be using dynamic memory. So dynamic memory. Dynamic memory comes from the system. It comes through an allocation API. The most common is malloc, calloc, realloc, free, and stirdup, and these are part of the C library themselves. And when you make one of these calls, it goes to the system and asks for a chunk of memory. And Storyboard is based on this API, and this is how we get our dynamic memory from the system. The reason we do this is because you want to create a dynamic UI, and in a dynamic UI, things are prone to change. And when things change, you need that backing memory to be able to show what you need to show. So, somebody's name changes, the string gets longer or gets shorter, you need to be able to have the memory to have that string show up on the screen. Sometimes it's easy to predict how much memory is needed, and I'll highlight these cases. And in other cases, you need to do a little bit more introspection, and I'll kind of go through how you can look at where certain areas may be using memory within Storyboard Engine, and sort of teach you how to look for those areas. And one of the things I want to highlight while going through this is that using dynamic memory isn't bad. You know, I don't want to make it sound like you shouldn't do it, but what we're hoping to do through this training session is to educate people on where we use memory so that you can make an educated choice on whether or not you want to use that memory for that thing, or if you have another avenue through which you can do something so that you don't use that dynamic memory. Some cases it won't even apply to you. Your system may be able to handle you know, lots of memory usage. If you have a system that has a gigabyte of RAM on there, you're probably going to be fine. You know, Storyboard runs on low-end platforms, high-end platforms. We scale very easily, but we run on low-end platforms that have less than a megabyte of memory. And so if we can run in a system that has less than a megabyte of memory, I'm pretty sure we can run in a system that has a gigabyte of memory. But it's still nice to know, you know, where is the application going to consume memory so that you can make an educated choice if you need to do that. Before I start, one of the key things about knowing where memory is going to be used is in pixel-based calculations, and these are used throughout Storyboard engine a lot because, you know, we're rendering pixels to a screen. So I just wanted to go over how we do a pixel-based calculation, and this is, you know, a fairly standard calculation. Just wanted to make sure everybody is aware of it. And the basic calculation is the width of the thing that you're drawing times the height of the thing that you're drawing times the number of bytes per pixel. And so a very, you know, the basic thing that you're going to need to know about memory consumption is your frame buffers for your display. We don't typically include the memory for the frame buffer in our calculations because you need the frame buffer. Whether you go with our offering or somebody else's offering, you're going to need a frame buffer. The frame buffer is necessary for the display, and so therefore you're always going to need one. So that's not a cost that is incurred because of Storyboard. It's a cost of, you know, doing a UI. So let's, you know, we can just run through what a frame buffer will cost you. And let's take a hypothetical situation of where you have a display that's 480 pixels wide by 272 pixels high, and you want to render at 4 bytes per pixel. So you can see the calculation there. It'd be 482 times 272 times 4, and that gets you about half a meg of space is what it's going to cost to store the frame buffer for the display. 522, 240 bytes to be exact. And then, you know, say that's a little too rich for the system that you're on. Well, you could also decimate it and you could go 2 bytes per pixel. And then that would half it, right? So now you're at 261, 120 bytes. So that's a basic pixel calculation. And this calculation gets used a lot. Like anything that is rendering to a screen, I'm going to be using this calculation. And these are the types of calculations that we can do up front and provide you information on. And then I'll highlight the ones that become a little bit harder as we go through. Also, once I'm done the part about the highest users of memory, we'll switch into the tool and we'll do some fun stuff in there, and we'll take a look at Storyboard Designer and how you can get some of this information. So we'll go through the boring slides first, then we'll do something that's interesting, and then I'll come back to one last boring slide, and then we'll go back to something interesting. So, you know, just, you know, we'll hold your horses, we'll get to the interesting stuff in a minute. Also, if I'm going too fast at any point when I am demoing the tool, just ask a question. I can always go back and revisit it. I have a tendency sometimes to, you know, let my enthusiasm about our Storyboard Designer kind of take hold of me and I start clicking. And also I've been using it for a long time. So if I go too fast through something and you really would like to know how I did something, please just ask and I will go back and let you know how I did that. So, highest users of dynamic memory within Storyboard Engine. So these are the following items that sort of contribute the most to dynamic memory usage. And the top one by far is images. UIs usually have a lot of images and content within them, and they use a lot of memory. And the reason they use a lot of memory is that basic pixel calculation. Width of the image times the height of the image times the number of bytes per pixel that image has, and that's usually 4 because a lot of images nowadays have alpha in them. So therefore, you know, your images can balloon your dynamic memory uses up quite high. Fonts are another area, not quite as bad as images, but they can still cause some dynamic memory growth there. Screen transitions. In our situation or in our tooling, when you want to switch screens, we have what's called a screen transition. They can also use a lot of memory. the canvas render extension, it's like an image that you get to dynamically draw to. So however big your canvas render extension is going to determine how much memory it's using. And finally, Lua. Lua is the one where, when I talk about having to do a little bit of introspection, this is the one where you really have to look at it. It's very hard to predict how much memory Lua is going to need ahead of time. You have to look at it during runtime, and that's because it's a programming language. So you're free to do what you want as you go through it, and you know, construct your UI and make it dynamic using the scripting language. And when you do that, you know, you're probably going to use some memory. So I'll give you some tips on how you can take a look at Lua and you know, maybe pare it down and structure it in such a way that it doesn't use as much dynamic memory. So just a note on images, why they use dynamic memory. Images are typically stored on the file system in a compressed format such as PNG, JPEG, or GIF, you know, however it's supposed to be pronounced. This compressed image data is then fed to a decoder, and that decoder is responsible for taking that compressed data and putting it into a pixel format that can be displayed on the screen. That decompressed data needs to be stored somewhere. So it needs to be stored in memory. So it acts as a scratch pad for the dynamic image data when it's uncompressed, so that it can be displayed on the screen. That's why images require dynamic memory within Storyboard Engine. And if you want to see a more in-depth dive into images, we have a YouTube session, the link's there. And it's done by our VP, Tom Fletcher, and it's a tech talk. And he basically goes in depth into images and all the different options that we have. So if you'd like to take a look at that after this one, feel free. The next one is fonts. Fonts are similar to images, very, very similar to images. The glyph data, so the character data is stored in a TTF or OTF file. And this is the data that is needed to generate a glyph for like an A, a B, a Y, whatever you're rendering, whatever character it is in the string that you're trying to push to the screen. That data is stored in a TTF or OTF file, and then that data provides an engine such as FreeType to construct what is called glyph data. And glyph data is basically an alpha map of what the glyph is supposed to look like. And the reason it's an alpha map is because you want to be able to colorize it after the fact. So basically, when you have an alpha map, it basically just tells you the pixels, the level of transparency that a pixel should be. And so you can apply a color, any color you want, and then that color will be what the glyph is drawn with. So that glyph data needs to be stored somewhere, and that's where the dynamic memory usage comes in for a font. And FreeType will cache those that glyph data in dynamic memory, so that you don't have to keep looking it up and generating it over and over and over again. And that's, you know, an optimization that happens, and that's why dynamic memory is needed for fonts. Again, we have an in-depth dive into fonts if you'd like to take a look in that YouTube video, and that's myself and Toma Fletcher discussing, the different options that you have with fonts. But for this presentation, we're just trying to explain where, the dynamic memory is being used. Screen transitions. So here's another case where it's a pixel calculation, and when we do screen transitions within Storyboard Engine, what we do is we composite the first screen, the current screen you're on, into an off-screen memory buffer, which requires dynamic memory. And then we composite the new screen in dynamic memory. Compositing means you flatten it. You basically make it a static image. So you take all those elements in the UI and you push them all down into one image. And that's what we're doing. We're pushing everything that's on the current screen into one image, putting it in an off-screen container, dynamic memory backed. And then we do the same for the new screen. The engine does the same for the new screen, and that gets pushed down into an off-screen container, and it's backed by dynamic memory. This approach is taken so that the screen transition is very smooth. We want that to look, nice as the new screen is coming in. So you can see in this slide, if we were doing a screen path transition where the new screen is coming in from the right, all we have to do is keep drawing that composited image to the screen over and over again at a new position as the new screen comes in, and that gives you that nice effect of the new screen coming in. Just a note about screen transitions, the screen replace transition requires no dynamic memory because it is just a strict screen replace. I'm not doing any sort of transition between them. It's when you have to do a transition that we require this dynamic memory to sort of house the composited screens so that we get that smooth transition effect. The canvas render extension. The canvas render extension can also be thought of as an image. It's an image though that you can write to within Storyboard Engine. And this image allows you through Lua to modify the pixels. And so you can draw a fill, draw a rectangle, draw a polygon, but there needs to be a storage location where those modified pixels, where those pixels that you're generating can live. And that's where that dynamic memory comes in. And it's the same calculation that we've been using. It's the width of the canvas render extension times the height of the canvas render extension times the number of pixels, number of bytes per pixel that you're going to use within your canvas render extension. That's driven off of, 32 bytes in this case, or 32 bits per pixel, which is 4 bytes per pixel, because we want to be able to support alpha. And then when you're done drawing and we have to redraw the display, that memory is pushed to the screen. So that's the reasoning behind why we have to have a memory backing for the canvas render extension. Finally, Lua, and I should make a note at this point, we can pre-calculate how much memory we're going to need for the things that I've just listed. And as I was saying, Lua is the tough one because Lua, you can do whatever you want in Lua. You can go through and you can create massive tables, or you can read from a file. You have total control over how you want to design and develop your application. So, you're basically going to have to take a look at it at runtime and see how much memory you're using if you feel there's a problem there. And I'll show you some tips and some tricks that you can do to take a look at your Lua memory usage. Also, we have a white paper or a knowledge base article on how to modularize your Lua so that you only load the components of Lua that you need at a given point in time. By default, if you put everything in your scripts directory, then we just load all those scripts and try and execute them right then, or load them into memory in any case, and then execute it when they're needed. But there's ways that you can actually modularize it so that you only load the pieces that you need and unload them. So I'm going to switch over to our storyboard designer at this point and just take a look at some of the things that I've been talking about. So for anybody out there that's following along and wants to actually just play around with Storyboard Designer as I'm going, I started with the address book. So I can show you how to pull the address book in. I've already got it, so I can't go through the whole process myself. But basically, if you want to import a sample project, you can just click on this Import Sample Project button here. And I just brought in the address book, and as you can see, it already exists, so I can't do it, but you can click on any of these samples and pull them in. So I just decided to take the address book. It has a nice cross-section of images in Lua, so I felt it really worked for me to show you some of the things that I'm talking about here. So I pulled that in through importing the sample project. Another way you can import the sample project is File, Import, and then if you go to Storyboard Development, click on Storyboard Development, Storyboard Sample. And then if you go to Next, you get the same sort of effect. So those are a couple ways that you can import this sample. So if you'd like to follow along with me and try some of these things out while I'm talking about them, feel free. Start with the address book, and then I'll just show you the address book when I pull this up. So this is our sample, it's the address book. I'm going to run it with the software render manager. So I'm clicking on the simulator button that has the green gear in it. So there's the simulate, which will just take the default settings and simulate your application as it is. But then there's this other one where we can actually configure how we want to simulate. And I just want to make sure that I'm using the software render, and I am. So I could use the OpenGLS render or the software render. I feel the software render shows the memory usage better. So I want to use that one as I'm going through and talking about these options that you have available to you. I don't need to configure anything else. I'm just going to close it for now, and we'll come back to that in a minute. I'm going to go directly to the metrics view. So this metrics view, it gives you an outline of how much memory and storage the resources are going to cost on your application. So the metrics view can be found in the right-hand side panel. It'll have properties, outline, connector, and then here, the final tab is the metrics view. And what the metrics view will do is it will show you the overall memory usage that your resources are going to cost you and how much storage space they're going to take. And you can see, you know, I wasn't lying to you when I said that images typically take up the most memory, because you can see they dwarf everything else within this application. So they're taking up 10.33 megabytes of space, you know, versus 1 megabyte of storage. So let's tackle the images first. Again, if you're on a high-powered system that has a lot of RAM, 10 megabytes isn't a big deal. You should be okay with that. But you know, if you're on a lower MCU platform that doesn't have a lot of RAM, what are some of the things you can do? So I'm gonna first show you how you can limit how much memory is going to be used for your images within Storyboard Engine. So I'm gonna simulate, and you can see my application popped up there. And I'm just gonna pull up the task manager, the Windows task manager. I just wanna show you the memory of Storyboard Engine. So Storyboard Engine, this application here, it's using about 6.2 megabytes. I'm gonna start clicking around and we can see the memory starts to go up. Whoops, sorry, I clicked on the wrong thing there. Let's get back to where we are. So we click on this, you know, we're up to about 8.4, because we're not gonna count the console window right now, of memory. So 16 now. And this is basically, we're loading images as we go through the different screens. We're loading other resources as well. Lua is executing, so it's not all images, but for the most part, we're loading images as we go through there. So how would I control that? So I'm gonna point out the help contents where you would find some of this information. So if you click in the file menu bar at the top here, there's a help button. You click on this and you click on help contents. And then we're just going to look at plugin options, see what that comes up. This is the options for the engine. So Storyboard Engine and plugin options, just give that a click. And if we look down at highlighted plugin, which is, you know, a lot, we're going to just scroll down. We're going to take a look at the resource manager options. Because what we're trying to do here, images are considered a resource. So we're going to try and control the amount of memory that the images are going to use. And we have an option here which allows us to cap how much memory you're going to use for your images. So right now it says a value of -1 indicates no image cache. So we won't cache any images. So what we'll do is we'll go back to our storyboard simulator configuration, and we're going to specify this option that we've looked up. So we're going to do -O resource manager, comma, image equals -1. We're basically disabling the cache at that point. So none of the images are going to be cached when we're running, and we're going to run. So now if we take a look at our SB engine, the address book is only taking 4.6 megabytes, and as we click through, you can see we're sort of hovering around that 4.6. We're much lower than we were before. We're not growing sort of unbounded anymore. We drop back very, very quickly because the image will come into memory and then the image will go out of memory because we free that cache up. So that's one way you can limit it. You don't have to do -1. You can specify a size that you would want to have, and you can click on the resource details in the metrics view, and you can look at your screens, and you can say, okay, well, the largest screen I'm going to have as far as memory is concerned is this contact screen, and it's going to go up to 4.6 megabytes. So if I wanted to limit my app to 5 megabytes of image space, I could do that by doing image equals 5 megabytes inside of this right here, the simulator configuration window. So if I did that, I could say, okay, I never want to grow my image cache larger than 5 megabytes. And I'll put that limit on there, and you know that you don't really exceed that limit based on the memory that's being reported in the metrics view. So you'll always have enough off-screen memory or cache space for your images for any screen that you go through. So that's one way that you can control how much memory your images are going to use. And again, dynamic memory isn't evil. It's just if you want to have some sort of cost certainty with your dynamic memory, that is one way that you can achieve it using Storyboard Engine. Now, if you're on an MCU platform, your memory is probably a lot lower than that. In some cases, you have less than a megabyte. So even going, that low may not really be suitable for your needs. So I'm going to take you into the resource configuration because there's some resource export options that you can do in the MCU case where you can basically limit how much, eliminate the need for memory altogether, because the MCU platforms are a special case. So sorry, I went a little quickly there. So I'm just going to re-highlight how I got into the export configuration. There's this open folder with an arrow above it, and it's the edit export configurations button. So if we go in there, this is where you can control how your resources are exported when you export your UI from Designer. So one of the things we can do is I'm going to create a new export configuration. Let's say I am working on a MCU platform. On an MCU platform, we have something called the virtual file system configuration. So I'm going to just call this new platform VFS, and I'm going to switch to it. So now we have a metrics view within this view, so you can see the changes that you're making. You can see exactly what impact they're having on your memory. So the first thing I'm going to do is I'm going to an MCU system. It's a VFS system. I'm going to say I'm going to use a virtual file system. So this switches things over and it changes the options that you have available to you. So the first thing I'm going to do is native format is what I was talking about in my slide, where you're going to need a decoder to decompress the image and store the decompressed data into a scratch pad using dynamic memory. What we can do is we can leverage Designer and have it do that decode ahead of time in the MCU case. So we can actually say, I want to do a direct format. And what this does is it eliminates all of the memory that the image would need for that scratch pad. Because what we're going to do in this case is we're going to pre-decode the image, pre-decompress it. We're going to store it on flash as the raw data that needs to be drawn on the display. And because reading from flash is really, really quick, we can just read and push that to the screen. We don't need to dynamically change the image. We just need to push it to the screen so that you can see it. So this option will push the uncompressed data out to flash. And now you don't have to have that decompression step that comes through. So you've eliminated all the memory that would be needed by the images at that point. So you can see that our memory dropped by 10 megabytes by making that one change. And we now have our images stored in flash. So when I export this, that's what's going to happen in that case. So those are some of the things that you can do with images. Another thing that you can do with images, and unfortunately this is I can't show you exactly what you would do in this case, but you can also take a look at your images and you can see if there's an image that could be replaced with a fill. So if you right click on an image, you can do convert images to fills, because sometimes what will happen if you've started with a PSD file and you've pulled that PSD file into your application, it's coming in as an image. But maybe somebody's using a solid fill color for a background, kind of like what we're doing with this up here. Now, I say unfortunately because if I take a look at that image, there's actually some alpha at the bottom. It doesn't go all the way to the bottom of the image, so there's some alpha, so it's not a full solid color. So when I do convert images to fill, it won't actually find it. It won't be able to actually convert it. But if I were to change that image and make it just a solid fill color, I could replace it within my UI with just a fill color, and that's no memory for that image at that point because it's just drawing a fill. So that's another option that you have available to you for images, is that you could do you could replace that image with a fill color if it's only a solid color. So that would also eliminate that need for that memory for that one particular image. So those are some of the things that you can do with an image, with images within your UI, some design choices that you can make to limit the amount of dynamic memory that images are going to need in order to draw on your display. We can also take a look at fonts. So as I was saying, fonts are very similar to the to images, in the sense that there's basically just this alpha map of data that's coming out of the font file that you're trying to draw. So it's glyph data. So you can see here that our fonts, are only taking up 374 kilobytes. Again, on a system that doesn't have a lot of memory, that might be a lot. On a system that has a gigabyte, you're not too worried about the 374 kilobytes probably. Maybe you are. I don't know. I guess I shouldn't say that you aren't, but probably you've got bigger fish to fry if you're close to your gigabytes of usage. So one of the things we can do there, you can do the same sort of thing where you limit your fonts memory usage. You can do font equals, and then you can give it the number that you want to have for that. Unfortunately, it's kind of hard to see in this situation because our fonts don't take up a whole lot of space, but you can actually limit that. So you could put in here, 1 meg. I don't want my fonts to go higher than a meg. That would work as well. The other thing that you can do if you are in an MCU situation is you can basically do a very similar thing to the images, where you can create a rendering of the fonts ahead of time. So instead of using the true type font file at this point, what we can do is we can use bitmap fonts. And what the bitmap fonts will do is it's the same sort of thing that was taking place with the images. We're basically going to go through, we're going to look at your application, and we're going to look at the fonts that are in use and the point sizes that are in use within your application, and we're going to pre-render those glyphs ahead of time, store them in Flash, and then that way, when you go to draw, we just read the glyph data from Flash, apply the color to it, and draw it to the screen. So very similar to images. We don't need any memory anymore because we have everything we need ahead of time. In this situation, if you have dynamic font sizes, point sizes, you may have to have them ahead of time because we're pre-rendering the glyphs. You're not going to have that glyph at that size at runtime if the engine didn't know about it ahead of time. So there's some trade-offs there that you have to make. But if you really need to limit the amount of memory that your fonts and images are going to take, this is definitely an approach you can take, and it reduces that need of memory. Screen transitions. So for screen transitions, I sort of set something up ahead of time. So I'll show you a screen transition in Designer, default screen transition. So if we take a look at this address book sample, when we click on the delete button, we're going to do a screen transition. Sorry, when we get a delete screen event, we're going to do a screen transition to the delete contact screen. So that's this screen down here. So when we click on that button, that's what we're going to do, and it's a fade. So we're going to have to render the current screen into memory and the next screen into memory, and we're going to fade one in over top of it. So when we simulate and we click on the delete, you can see that fade took place, right? We faded it out, and we fade back in. So that's using the default screen transition. There's another way you could accomplish this. So I took the liberty of building up an alternate way to do that screen transition. It's almost the exact same. I called it address book alt screen. So I basically just copied this project, and then I pasted it, and I called it _ alt screen transition, or alt screen trans. And if we take a look at that, it's the exact same app, but the difference is the delete contact screen is still there, but I could get rid of it if I wanted to, because I'm not gonna, well, actually I won't delete it right now, but I could get rid of it if I wanted to. But the delete button, if we look at it, Sorry, it's not the delete button, it's the delete event, the delete screen. I now have an animation. I'm not doing a screen transition anymore. I'm going to do an animation. And the delete contact layer, which was already on our contact screen, I'm going to make use of that layer on my contact screen. When I delete a contact, I'm no longer going to have to switch screens. I'm going to stay on the exact same screen. And the way I accomplished this is I created a variable on the delete contact screen. I clicked on new variable and I called it alpha. Can't do that right now because I already have one. I set the value to 0. I made it a number and I set the value to 0. And then what I did is, if you take a look at all the render extensions on the delete contact layer, so we'll just take a look at one, but you'd have to do this for all of them. And it's not a big deal to do it for all of them because you can multi-select. But if you look at the images by clicking on the properties view, which is in the same area as the metrics view, it's just the first tab over, click on the properties view, you can see I set it to screen alpha. So I set the value of the alpha to the screen alpha. I clicked on this bind variable, so I'll unbind this one. So I'll unbind the variable first and I'll show you what I did. I clicked on bind variable, I went to contact screen and I found that alpha variable that I added, and I said, yes, bind it to that. So now I've got this screen alpha variable tied to that render extension's alpha value. So when I change that screen alpha value, the alpha value for that render extension is going to change. And I did this for every single render extension on here. And I know that sounds like a lot, but it really wasn't that bad, because all I had to do was sort of expand these out and multi-select. So I just went through, found all the render extensions, multi-selected them. I won't do all of them again, multi-selected them, and then I just bound them all using this button here. I bound them all to that screen alpha value. So I switched it over fairly quickly. I then created an animation. So I went to my animation, I have my show delete contact layer. And what I did in my animation, I basically said I want a new animation, so add animation, and I'll create a new one just for the sake of creating one, but I already have one. So new show delete contact layer. And I'll click on OK. And then when I look at this, it's an empty animation, but I can right click in this white area and I can say add animation step. And I went to the contact screen and I said, I would like to animate the alpha value. And I want it to start at the current value when the animation runs, and I'm going to animate it to 255. So that's all I did. I'm going to change it from being completely transparent to completely opaque over a period of time. And so that was the first step I added. The next thing I added was that this delete contact layer is hidden. So you can see it won't even show up when I unhide it because everything's alphaed out, but it's completely hidden. So I need to unhide it first. So I added another animation step. So again, sorry, right click in the white area, add animation step. I went to contact screen and I went to delete contact layer, and the GRD hidden, I set it to off. And I set this from the current value when it runs, and I want it to be off. So now the first thing I'm going to do is I'm going to make it unhidden, and then I'm going to animate the alpha. So that's how I created it. I just created that animation. So then I have this new animation, and then when I want it to go away, I need that animation to sort of do the reverse. So I went back here and I right clicked on new, well, in my case, I right clicked on show, but you can right click on new show delete contact layer, and you can just click on add reverse animation. And that puts in the reversed animation. So if we look at it, it goes from the current value, which hopefully will be 255 when we run that animation, back to 0, and it hides the layer again. So I've now set up my two animations that I need to have happen to show and hide that layer without using a screen transition. So if we go back and we take a look at the actions for the delete button, Sorry, yeah, it's using a delete screen event. That kind of throws me sometimes, I apologize. So the delete screen, I switched that to be an animation. So I just clicked over here and it was a screen transition, and I just found animation in that pop-up list that came up, selected animation, and I just told it to use the show delete contact layer animation. I switched that in the properties over here. So now I've switched that. The other thing I wanted to do is on the no button, I wanted to, the no button before, if you look at the default application without any changes, the no button before was actually doing a screen transition back to the contact screen. So I changed that to be an animation that was the reverse of what I was doing before. And now if we look at that application, when we run it, when I click on this, if I click on the delete button, I get that nice fade, but without using a screen transition. So it's another way to accomplish that same effect. I get that fade, but I don't have to incur the memory cost of having those screens stored in off-screen memory. So another way to approach your UI design, get the same effect. So you don't have to do it this way. If you have the memory for screen transitions, it's easy to set up the screen transition. I want to go to the screen. You know, sometimes it's nice to have content broken up into screens so that we know what that screen is doing. Having a singular screen and a whole bunch of layers, it could get confusing, but you know, it's another approach. It's another way you can look at it and accomplish the same sort of thing and reduce that amount of memory that's needed. And again, it's about educating yourselves on when the engine is going to use memory and what options you have available to you. So knowing that the screen transition uses memory, okay, that's good. I'm okay for memory, so I don't need to worry about that. I can just use the screen transitions. Or I'm on a system that doesn't have a lot of memory, so I can't use complex screen transitions, but I still want to get that effect. What are some of the other options that I have available to me? And this is one approach that you could take. So for the canvas control, you know, if you're using the canvas control, you're gonna incur that memory storage. There's no way around that. You need that memory storage. Some things that you could reduce the memory usage, make the canvas control smaller. See if there's a way you could make it smaller to do the same sort of drawing. Because as you make it smaller, the amount of memory needed is also going to get smaller. But the other approach would be, what are you actually using your canvas control to draw? You know, are you using it to draw rounded rects because you didn't see previously we had the ability to do a rounded rectangle? So if I draw this control out here, you know, this rectangle, you know, now we have the ability to do rounded rects. So maybe that was the problem that you were running into, and you used a canvas to get around that. Or dynamic polygon drawing. Are you doing dynamic polygon drawing? Investigate the polygon control. Perhaps there's a way you can leverage the polygon control to do the same thing, and therefore you won't incur that memory cost. Again, it's a design decision. Maybe you have to use the canvas control. Again, using dynamic memory isn't evil. You have some, you can use it in some cases, but it's knowing when it is to make that right choice of, can I use that memory right then? Do I need to use that memory right then? Do I have that available to me? So we're gonna move on from those. Those are the known costs up front. You can calculate those, you know, doing some simple math or by looking at the metrics view, what, you know, images, fonts, screen transitions are gonna cost you. The canvas render extension, what it's going to cost you, those are known. Now we're gonna look at Lua. So how can you figure out whether or not your Lua might be taking up a lot of space? So I copied and created a new address book, and I created it and I called it address book GC, and GC stands for garbage collector. So I'm going to close this one. Sure, save. And so the address book GC, it has no changes to the actual UI itself. There's no changes to the UI itself. If you look in your actions view, which is down at the bottom in this tab group, it's the second one over. If you look at the actions view, you see on GRE init, we're gonna go into this Lua call, which is CB init. In the properties view, which is on the right-hand side, if you click on the edit button, we can jump into that function. And if you do so with your current address book, which you've imported, you will see that I have added this line. What that line does And if you want to take the time to type it out, go right ahead, but you'll also need this function up here, and I'll get to that in a second. What this line does is it sets up a timer interval within Lua to fire every 500 milliseconds. And every 500 milliseconds, I want to call this function called cbPrintMem usage. And what my cbPrintMem usage is going to do is it's going to call this function called collect garbage with the parameter count. And what that does is it basically runs through the garbage collection for Lua, and it basically says, okay, how much memory am I actually using at this point in time? And it will print it out. So we can run that and we can take a look at it. So I'm just going to run it, and you can see we're printing out data right off the hop. This is how much Lua is using. Now, you're probably saying, oh my God, it's leaking memory, it's going up. I want to point out that I'm printing something, that's a string. So every time I'm printing, I have to generate a new string. That's probably where the memory is going right there. So it prints out what Lua is using. So you can see the number was going up. Lua uses a garbage collection system, which means that it doesn't free things right as soon as you're done with them. It holds on to them thinking you may need that again, so let's just leave it. We'll see if we can make use of that memory some other time down the road. So it just kind of leaves it there. At some point in time, the garbage collector will run and say, what don't you need? And it will go through and just rip all that stuff out and get rid of it. So that's why the number's going up, because it's just basically holding on to that garbage over and over and over again. It's, you know, basically filling it up, not worrying about it. So you can see, yeah, the memory goes up. And as we go through and we click on different screens and we invoke different Lua calls, you know, the memory jumps a little bit more. The big one is when we go to this one and we start looking at, you know, the ability to sort of edit and add contacts. You know, we're adding in more Lua, or we're exercising more Lua in that case, so it's going up. So what are some of the ways that you can control your memory usage when you're using Lua? So I'm going to click on the storyboard simulator configuration again, and we have the ability to tell the GC to be a little more aggressive. So every time a Lua action is invoked from Storyboard Engine, we can tell it, hey, I want you to run the garbage collector when you do that. So what we can do is we can do -o Lua GC equals 1. What that option is going to do is it's going to tell the Lua engine to fire the GC after every action. So we're gonna run the GC a little bit more. So now when we run our application, you can see we're kind of holding steady at a lower number. And even when we go into some of these other values, we're at a lower number because we freed up a lot of that garbage. We're freeing up that garbage a lot sooner than we were before, previously, when we were holding on. We're a little more aggressive as we're going through. Now, you are firing the GC more with a higher frequency, and that means that it's going to take a look at what's in its garbage list. There's a CPU penalty there. It may affect performance. It may not. It depends on how much garbage is there and how much it actually has to free. So just be aware of that, there's a reason we don't turn it on all the time, and that's because the GC is going to take some CPU when it runs. But maybe that's okay. Maybe, you know, you don't have a lot of garbage, you just kind of want to keep it at a certain bare minimum. So by doing that, you're going to keep it lower. So that's one option you can do. You can turn on the GC and have it fire every time you go through. If you don't want to do that, then we can modularize our Lua a little bit. And I've created this address book segmented application. And what I've done in that is I've broken out, here, let me go back to my project. When Lua scripts are loaded, everything that's in the script directory gets loaded by Lua by default. So when we start up the engine, these 3 Lua scripts are going to be loaded right off the hop. If you don't want something to be loaded as soon as the engine comes up, create a directory and put your Lua scripts in it, and those scripts will not be loaded. So what I did is I refactored the contact add and the keyboard Lua files, and I moved them into this separate directory. And now they're not going to be loaded when the engine starts up right off the hop. Whereas before, in the scripts directory for the GC, they were coming in, and that contact add and that keyboard, that functionality was being loaded right as soon as the engine was fired up. The issue is that we don't need that functionality until we click on the add contact button or the note contact button. We don't need that because we don't need to add a contact until we're in the add contact screen. That Lua functionality is associated with a screen, so we don't really need it right off the top. So we push it away. We defer the loading of that Lua to later, and I'll show you how we did that. This is covered more in depth in the modularizing Lua knowledge base article that I provide a link to in the slides. So if you go to that, you will see you'll see how to do this a little bit more in depth. It's spelled out a little bit more. So I'm taking a very high level approach to this, but if you need to understand how to do this, I would recommend reading that article because it's a step-by-step guide on how to do it. What I did is when we're going to switch screen to the add or input screen, I have this CB load input edit code. And what I'm doing when we're in there is I'm going to pull in that Lua code at that point. And I'm going to basically call the same function that I was calling before, which is the CB setup entry. I'm going to call that directly out of the contact add. I have to make that specific call at that point. Then when I unload that screen, I'm basically going to unload those packages. And then I'm going to call garbage collect. I'm going to force the garbage collection myself. So I'm going to collect garbage and I'm going to tell it to collect. What this will do is anything that's in that contact add or keyboard is going to free it up for you. It's going to remove it from memory. It's going to drop your memory usage at that point. So we can get to that point where we're not using as much memory when we're not needing to be in that screen. I had to structure the contact add Lua more as a module, and these are the steps that you'll probably want to refresh yourself or get to know by reading that knowledge base article, because you have to basically set your Lua up as a module at that point. So the main difference is that any function, if we take a look at the original contact add, you can see it's not a module, it just has functions in it that are added to the global namespace. Now what I've done is I've restructured it so that these are a part of the contact add class, and basically they're functions that you can use only through contact add. They're not globally accessible anymore. So if contact add doesn't exist, you can't call these anymore. So there were some changes that I actually had to make to the application to do this. Same with the keyboard. There's a keyboard CB keyboard press that I needed to, I added to the actual keyboard class. I did the same thing. I created a module keyboard and I went through that. And basically then we just have to structure the application so that it knows where to find those functions now. So if you look at the keyboard here, sorry, that's not the right one. There's one in here where, yeah, maybe it was just we basically have to call that function directly out of the class. And that's where that would happen. So now when we run, so let's run our address book segmented. So I'm gonna run this one. It does not have the GC flag set. So there's no GC flag on this one. When I run, you'll see the memory usage is lower than what we were getting before. And then as I go into a contact to edit it, the memory usage spikes. Now we've just loaded a whole bunch of data on the fly. So that spike went up. So it went up a little bit higher. But when I cancel and then come out, you'll see that we drop back down. We've collected all that garbage that we didn't need anymore and we've gotten rid of it. So we've dropped back down. So yes, you are going to have some spikes, but you can modularize your Lua to the point where you're only ever using what you need. And as long as you call that collect garbage function, then you're going to free up that space. So you know, that's an approach you can take to make your Lua less memory hungry as you're going through and writing it. And I should point out that these are all numbers in kilobytes. So that's how much Lua is taking in this particular app, kilobyte wise. And again, if you've got a whole bunch of RAM, it may not be a big deal, but on some of these smaller systems, you know, 132 kilobytes is a lot of memory. So you want to make sure that you can structure in such a way so that you don't hit that high watermark. So those are just some of the approaches that you can take, and we wanted to make you aware of the approaches. You know, in some cases, maybe I've gone a little bit too quickly or you need a little bit more explanation. As Scott said, don't hesitate to contact us. We can go more in depth, but we wanted to make you aware that there's other approaches you can take. You're not locked into one specific way of doing things with Storyboard Designer. And, you know, in an effort to get your UI up and prototyping quickly, you may have taken one path and it doesn't quite work on your target system. Well, there's probably another way we can approach it so that you're going to be successful on your target as well, and you get the same look and feel as you do with that, with the way you've done it for your prototype. So I'll just jump back into my slides. The last slide, the other areas that you need to know about that can use some dynamic memory, Storyboard IO. Storyboard IO is how we connect the backend application to your UI through a message passing channel. This, on the higher end systems that are using OSs like Linux, QNX, Windows, there isn't as much of a memory impact here because we leverage the message passing systems that they have, such as System 5 message queues or Windows mailboxes. We can leverage those. Where you still will see an impact is when the message comes in. If there's a lot of message data, that has to go into the event queue. So you're basically grabbing an external event and pushing it into your event queue. And that event queue expansion could trigger a growth in memory. And you'll see with Storyboard IO on a lower end system, that Storyboard IO, because of a FreeRTOS or a ThreadX, may not have a message passing system. That queue, or that sort of between tasks, is done in memory. So you're going to take a bigger hit there. So on a lower system that's using FreeRTOS or ThreadX or some sort of real-time executive OS, what you could do that's a little bit different there is you can get rid of Storyboard IO altogether, because in an MCU world, you have access to everything. You have access to the app pointer. So you can actually just push your own events in as you see fit, or you can respond to events any way you want. You don't have to go through Storyboard IO. Storyboard IO is mainly its main use is in the bigger systems where there's memory protection and you can't have access to the engine's memory from an external application. So that's another approach that you can do on a low-end system to get rid of Storyboard IO. The event queue expansion, I'll touch on that again. If you're in a system and your system's under load and you're generating a lot of events, there's a chance that the event queue will have to grow if it can't keep up with the events are drawing. It starts out as 4K and it will double as it goes through to store the data that it needs inside of the event queue. So that will grow. So that's something, it doesn't happen a lot, but if it does happen, that's something to keep an eye out. And you can log event queue messages. You'll see a message on your console that says that the event queue is actually growing. And there's actually an option that I'll show you in Designer in a minute where you can actually cap how big your event queue will grow. Now, if you cap your event queue, you may lose events at that point, because if it can't fit, it will just discard the event. Tables, clone controls, and scrolling layers. These will also these are also areas where you could create the use of dynamic memory. Tables, if you have a whole bunch of rows and columns and you have a whole bunch of different table cells that have a different configuration, then there's a control that's going behind all those. So if you dynamically add or shrink or grow your tables, you're going to be fluctuating the dynamic memory that's used with those. So be aware of that. So there's some things that you can do. The infinite list example is a good example of how you limit what you want in your table and still kind of get that, you know, dynamic scrolling, big list sort of appearance with your data. Clone controls from Lua. If you're cloning a lot of controls, this is going to create dynamic memory because the control needs a backing structure. So as you go through, if you create a lot of dynamically created cloned controls, your memory is going to go up. So you need to keep an eye on that as well. Scrolling layers. When you enable scrolling layers, the scrolling information needs to be stored for that layer. So that's going to incur an additional little bit of memory. So that's something to keep an eye on. How many scrolling layers? Do you need to have your layer be scrolling? Is there some other way you can get the same effect by just moving controls through in the layer? Polygon and circle render extensions. These require some dynamic memory to store the points that are going to be used to render the polygon or the circle. It's a low amount of memory, but you should be aware that it could be in use. And when I say low, it's less than 4 kilobytes. But again, on a system that you don't have a lot of memory, that might have an impact. So be aware when you're using a polygon or circle render extension that there may be a dynamic memory use there. And data variables. Dynamic UIs require dynamic data. And so if you have strings coming in that you want to change, be aware that there's memory that has to back that string. So when you're creating, if you create a huge long string inside of your data variable, that string has to be backed by memory. So, you know, some place where this might come into play is translations. What can you do with translations to kind of limit what you're going to need? You know, pushing your strings statically so that you don't have to allocate and free them and just change pointers to them. So just for on the Storyboard IO, you know, one thing that I can do, I can show you, I added this, I'll show you where the Storyboard IO can take effect. I added an event in here. So one of the ways you can look at the events that you've created, you can click on the top menu bar. There's what we call the screaming E, affectionately. It's this E that looks like it's screaming, but it's actually the event editor. You go in there, you can add an event in. So if I add in something like contact add, let's say we wanted to have a back-end application add contacts into our event. One thing we could do is we could create this contact add. Now, when we're creating this event, when it's coming in, there's probably going to be data associated. You know, maybe you're getting a JSON string, so you set it as a string 1S0, and you're pushing all that data through all at once. Well, maybe there's another way you can change that up. Maybe you don't need that. Maybe you can break it up so that you can use some more known entities like an integer or a float, and you don't have to push all that data through as a big long string that has to be stored in memory somewhere. Because what's going to happen is when that event gets pushed into the event queue, that string data is going to have to be stored in the event queue. So if you have this huge, you know, 500 kilobyte string of data, that has to go into the event queue. And finally, I'll just show you how you limit your event queue size. If we basically go back to the help contents and take a look at plugin options, if we scroll down, queue size, you can limit how much. So if you went and did IO manager, comma queue size equals size, you can limit how much space you want your event queue to take. And again, you know, there will be messages that are dropped if you exceed that queue size. But if you want to make sure that you never go bigger than that, that's the way to go. I wouldn't recommend doing this unless you're in a really, really tight situation. Again, if you have the memory, using dynamic memory isn't evil. You can use it. But you know, you may be in a situation where you do have to limit the queue size, and that's how you go about doing it. And again, you just would go into your simulator configuration, and you would basically, in here, you would specify IO mugger underscore mugger, and it would be queue size. And if I wanted to limit it to 4096, and I knew that no event was ever going to have more than 4K of data, I could do this. And then I just have to make sure that I could keep up and pull those events, because it's not just about one singular event, it's about all the event data total as it's going through. So that's pretty much what I had to present today. Scott, if you want to take over, I can give it back to you.
Perfect. Thanks, Rodney. Great information there. Thanks for taking time out of your day to present that to us. The little bit over time is well worth it to cover off all the great things that you provided us with today. So just before we wrap things up and jump into the questions, just a couple of key takeaways. Definitely, like I mentioned before, if you haven't gone to our help center, definitely give it a check out. There's a lot of great information there. If by chance there is something that you're looking for that pertains to storyboard and UI development that's not there, reach out to us. Definitely the team is very responsive, and we can help you out as best as possible. So, you know, that kind of dovetails into the last one that, you know, definitely feel free to reach out and connect with Crank Software And whenever you need it, if your project needs it, feel free to leverage our expertise with GUIs on your next project. So with that being said, it's a perfect opportunity for us to jump into the questions that have been posed. And so as I'm just kind of opening that up, now is your chance to definitely pose any additional questions that you may have. So feel free right now to get them out there as I just kind of jump into that right now. All right. So Rodney, you still with us? The first question I have for you is, if the 16-bit per pixel frame buffer takes less memory, then why not use it all the time?
Oh, that's a great question. So yeah, the issue with that is you're going to lose color fidelity, which means that you don't have the range of colors that you would in the 32-bit case. So let's say you have gradients in your application. You may get what's called banding in your application if you use 16-bit. Now, there's workarounds in that situation, but you know, that's the trade-off, is that you don't have the range of colors that you necessarily would in a 32-bit situation.
Cool. Next question is, why does the decompressed image need to be stored in memory? Couldn't the engine just decompress it again when it needs it?
Yeah, so when I did the -1 in that sample, that's essentially what we were doing in that case. It's hard to show on a desktop, but when you're going through, we have to reload that image, and you're reading from a disk and you're decompressing that data. There's a CPU hit that you're going to take when you do that, and depending on how fast your I/O is, you could see some slowness when you're trying to render your UI the first time through because the image isn't in memory. So that cache is really there to sort of help with the amount of CPU it takes to draw an image. So that's why it's not there by default, because we're trying to provide a responsive UI in most cases.
Perfect. Another one regarding canvas rendering. As the user is drawing rectangles, is there a way to tell the Canvas API draw now, so all the drawing operations can be done before the update, or is there an optimized way to draw into a canvas?
You're rendering from Lua, and we're in a main thread. So what you're doing is those commands are being executed into the Canvas render extension. Once it's in the Canvas render extension, it's there. So if you don't have to make any changes, we use it and cache it and use it over and over again. So the most optimal way is the way that it's being done, because what you don't want to do is stall the responsiveness of the UI because you're drawing in the canvas. So basically it's like caching this pipeline of events. And then when the canvas needs to be drawn during a redraw event, we look at it and we say, okay, it's dirty, it needs to be updated. Then we will generate the content and push it to the screen when it's needed. If nothing changed, we just use the old value of it and push that to the screen. So the current way that it's sort of implemented works best within our framework.
Perfect. Another one, this one's kind of going back in history, is that I don't see the metrics view that you showed on 5.2.1. When was this introduced?
It was introduced in the 6.0 timeframe. During that time, you know, we were making a big push to support MCU platforms a little better than we had in the past, and we felt that for those particular platforms, you really needed to be able to see how much your resource was going to, or how much your resources for your UI were going to take. So that's when we added it in for 6.0. So unfortunately, yeah, it's 6.0 and forward is where the metrics view is.
Okay. What determines how big the glyph data is for an individual glyph in a font?
It's your point size. So your point size will scale the glyph data so that, you know, it encompasses what you need. So, you know, if you're rendering fonts at 92 point size, those glyphs are going to be bigger than, say, you know, if you rendered them at 48. And in the case of the bitmap font, where this kind of plays in is, even though we're not taking up the memory anymore, we have to store that in Flash. So if you have this big font that has a lot of characters in it and you want to render them all at 96 point size, then, you know, you may notice your storage is actually starting to run out at that point. So there's a couple of approaches you can take there, where you can actually strip some symbols out of the font file, make it a smaller font file, or, you know, maybe figure out if there's another way that you can accomplish the same thing with maybe images.
Okay, I got another one that kind of is in the family of fonts and glyphs. Going back to 5.2, In 5.2, only black and white emojis were supported. Are color emojis currently supported? If not, are they coming soon?
They are coming soon. They are coming in 7.0. So we have that on the pipeline, and it's being worked on as we speak.
And just to let everybody know, it's on this call, 7.0 is the next main release that's coming out, that's scheduled. So you'll hear more about that in the fall timeframe. Perfect, thanks, Rodney. A couple more questions. Are the dynamic allocations required by render extensions shared?
Yes, they are. So if you're referencing the same image in multiple render extensions, you're not copying that image multiple times all over the place. It's once. So once we have the decoded image data in memory, multiple render extensions can reference that memory. The same with glyph data. Once the glyph's in memory, you know, if it's the same point size and the same font file, then we can just reference that. The engine can just reference that glyph data multiple times.
Perfect. One last question. The modules you added in Lua, are they built into Lua or did you create them yourself?
I created them myself. So what I did is I took that contact add.lua file and I turned it into a module. So I actually just took that Lua file and I turned it into a module right in place. You know, I basically refactored the code so that it became a module. And that's something I did. And that's why, you know, if you go to that modularizing Lua knowledge base entry, we explain how to do that. And it's actually a really good read. I would recommend people take a look at it.
Perfect. That's a good call to bring that up again, because that was a recent addition into the Help Center and into the knowledge base set of articles. So, well, thank you very much for your time, Rodney, and thank you very much for everybody that was able to join live today. As I mentioned, this is something that's an ongoing series that we introduced in 2020 to really advance your awareness and knowledge on Storyboard, and we do it around the last week. Typically around Thursday of the last week of every month. So stay tuned. Next month's is going to be on design states. So thank you very much and enjoy the rest of your day.